Okay, so in this video, I'm going to show you guys how to take some word problems and turn them into some functions. Tomorrow, we'll go through and actually answer the parts of the question that are talking about specific values, like what's the maximum width or maximum height, things like that. But today is just about writing equations, all right, writing functions based on some information. So I'm going to zoom right in on problem number 1 here. We have a word problem, so I want to annotate it as I read. Okay, so a builder is designing a rectangular parking lot. He has 400 feet of fencing to enclose the parking lot around 3 sides. This is really important, okay, that we're only covering 3 sides. It says, let X represent the length. Okay. So we have a picture here that goes with our problem, which is nice, okay? And it says to let X represent the length. So we have a length right here, so I'm going to go ahead and mark this as X. Now, if you remember anything about rectangles, the opposite sides of a rectangle are equal. So if this side of the rectangle is X, I'm going to go to its opposite side, and this side is also X, okay? So now what I have to figure out is what this width is. And I can't call it X because I don't know if it's the same as the length. And so I don't know. What I do know, though, is I have 400 total feet of fencing. So I can't call this 400 because then I wouldn't have any fence for the length. But what I can do is take the total fencing and subtract off the fencing that would have been used for each of the 2 lengths. So 400 is my total, and then if I subtract off this length over here on the left and subtract off this length over here on the right, then that would give me the width. So this width is 400 minus 2x. Okay? Now, if we look at our function, we are asked to define a function to represent the area. Now, if we remember, the area of a rectangle is either, all right, it's either length times width, or it's also known as base times height. Now, obviously, in this problem, it's length times width because those are the dimensions we're working with, but either one would work. So it says define a function a of x. So a of x to represent the area of the parking lot. So I'm going to take my length here of x and multiply it times my width here of 400 minus 2x. So x times 400 minus 2x. Now, this particular problem does not ask us to multiply it out, so I'm not going to. All right, it just says define a function. I've defined a function. Okay, so in this case, it was, again, area is equal to the length times, and I'm going to actually use the little multiplication dot, so times the width. That way you don't think there's an extra x in there. All right? So there's nothing else with this particular problem. We could do more if we knew more, but this is our function. Okay? So I'm going to go ahead and do the same type of idea for problem number 2 here. Now the picture looks drastically different. All right, so let's get into the word problem and actually annotate it to see what's going on. Okay, hotel is installing a rectangular swimming pool with square hot tubs on each end. The combined length of the pool cannot exceed 22 feet, and let X represent the width of each of the square hot tubs. Okay, so if we know anything about hot tubs, if we know anything about squares, all right, X is the width, but a square has all the same dimensions. So if I look at this, this is the hot tub right here, this is the hot tub right here, okay? So this is X, 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 and X, and so is this one. All right, it's X's all around. And says, define a function to represent the area of the swimming pool. So this is our swimming pool right in here. And if I want to find the area of this swimming pool, I'm going to need to know its length and its width. Okay? So we want to kind of look at what we're given and figure out if we can work with it. So clearly this width here is x. All right, that's kind of nice to know. Rectangular, so it's x on the other side too. What I need is this length. And the problem is this 22 applies to the whole length, including the hot tubs. So I kind of want to work my way back in and subtract off these two edges. So this shaded region is going to be 22 minus the x that I have here for the hot tub on the right, and the x that I have here for the hot tub on the left. So that was 2x's that I subtracted, so minus 2x. All right. So if we're looking at the area of the swimming pool, we would have a of x, right? That's our function notation, is equal to width times length. And it doesn't really matter what order you write it in. It's just that you make sure that you're multiplying. All right. Now, part B talks about very specific values. So that's the part that I'm going to hold off on for tomorrow. We'll get to that. But for today, all I want to focus on is getting good at writing these functions. All right, so I'm going to go ahead and stop with problem number 2. We'll go back to it, but for right now, that's the end of 2. Go ahead and slide on down to number 3 here. All right, so we have a word problem. Same thing we've been doing. Read it, annotate it. Let's see what we've got going on here. So Juanita is making a poster, as shown in the diagram, with a width of 5x, kind of an odd little width, and a height of 3x, where x is in feet. Okay. 2 feet of material on each side is white, as shown. Okay. So define a function a of x to represent the area of the shaded space. Okay, so shaded space is just this part right here. Now, the nice part is we know one of these dimensions. It says we have a height of 3x. So if it's all a big rectangle, this is 3x right here, this is 3x right here, and this edge would also be 3x. All of these vertical edges, all right, are all 3x. Okay, so if you want to label them across, you can. It's just to make sure you understand that that's across the rectangle, all of those would be the same. Now, it says for this shaded region, we've got this edge right here, which would be 2 feet. And we've got this edge right here, which would be 2 feet. So we want to take that 5x that we had for the whole width and subtract off the 2 edges that were those little white strips. So we've got 5x minus, well, we've got 2 here and minus another 2, so it would be minus a total of 4. Okay, so area again, we're talking about a rectangle, so we're going to do area a of x is equal to our width, which is 3x, times our height. Actually, I said it wrong. The height was 3x, and the width is just the shaded part, 5x minus 4. All right, so that is our handy-dandy area function for the shaded space. Okay, again, I know Part B has some more information. We'll get to that, but for right now, again, I just want to focus on the writing the functions. All right, so number 4 here. Let's see what we've got here. Franco is painting part of a wall gray, as shown in the diagram, with a width of 4x and a height of 2x, where x is in feet. All right. And 1 foot rectangular spaces will be left white as shown. Okay. So if I look at just the imaging here, right, just the picture, I've got this little piece right here that's going to be 1 foot of little white space. I've got this piece right here that's another 1 foot of white space. And I've got this edge over here that's one foot of white space. It helps if I actually write the 1 as opposed to just the FT. And then vertically, if we look at all of these, let me change color here actually. If we look at all of these vertical pieces, all of these vertical sections would be the 2x because it's all rectangular, okay? So these are all 2x all the way across. So I want to look at part A here. It says to represent the area of the shaded space, okay? So I want to make sure I'm just looking at the shaded space. Well, the total width was 4x here. But I have 1, 2, 3 total feet of white space that we're eliminating, right? We're not going to count that as part of the shaded region because it's not, okay? So the function here, a of x, is equal to, in this case, we're going to do the height of 2x times the width of 4x minus 3, okay? So this is our function that's going to represent the area of just the shaded space, all right? Again, we'll get to part B. I'm not going to worry about that right now, all right? I believe there's one more, so let me kind of scroll down here. I knew there was one more. All right. Problem number 5, last one on the page. All right. Home improvement show is designing a backyard. I kind of wish somebody would design my backyard. All right. I digress. In the backyard, they have a space 50 feet to install a pool. Sounds kind of interesting. Then install rectangular sections of garden on both sides of the pool, a width of x, and a length of 3x as shown, okay? And so we want to represent in part A here the area of the pool. So the pool is just the shaded space, all right? So that's what we want to be careful about, is that we're just looking at the shaded space for our area information. So I'm going to go ahead and scroll in really tight on, or zoom in really tight on the picture, all right? So we've got all of these vertical lines here. Because it's all a big rectangle across, all of these are going to be 3x. Okay, it doesn't matter if you're looking at the left side, the right side, the pool, the gardens, all of those rectangular pieces, those vertical edges are going to be 3x. All right, we have this total, what was this word? The 50 feet. All right, I guess that's part of the width. We have a total width of 50 feet here. But the pool is not 50 feet because that would mean we don't have any gardens here. And maybe you don't want the gardens, but this is how they're designing it. All right, so we're going to take this 50 feet and subtract off these garden pieces, these garden widths, to just get down to the pool. All right, so this edge right here is x, right, just like its opposite side. This edge right here is x, just like its opposite side. So this part of the pool from here to here is going to be 50 feet. That's the total width, minus the 2 x's that would be used for the gardens. Okay, so if we're looking then, I'm going to scroll, zoom out here. If we're looking at the area of the pool, all right, so that's going to be a of x. That's going to equal the length of 3x times the width of 50 minus 2x. All right, and that is a function that would represent the area of the pool. Okay. All right, so there's going to be a second video, or there's going to be a video tomorrow that will go through all of these problems for part B. But before you get to that one, if you have any questions or concerns about writing these expressions or equations, please message me and let me know what I can do to help.